We might not need to bother with any of these blade inspections because vertical axis wind turbines are coming back. Did you hear the news? So if not, let me tell you. Let me tell you.
Please.
Welcome back. I'm Dan Blewett.
I'm Alan Hall.
And I'm Rosemary Barnes.
And this is the UPTIME podcast, bringing you the latest in wind energy tech, news, and policy. Welcome back to the UPTIME Wind Energy Podcast. I'm your co-host, Dan Blewett. On today's show, wide range of topics here in the new year. First, we're going to talk about GE. They've had a blade break in Germany, and there's some investigation underway. We'll talk about the implications and speculate a little bit about what might have happened. We're going to talk about vertical axis wind turbines. Rosemary, you're excited, I know. They continue to pop up and continue to have support, though perhaps maybe a little bit unfounded. We'll talk about some ocean hydro storage batteries, microplastics shedding from wind turbine blades, which is an interesting topic that we haven't discussed yet. We'll talk about some ways to repurpose blades, an interesting method of dismantling an old farm, which is being done in North Dakota currently, or at least proposed. We'll talk about a little bit of the offshore wind environment here in the U.S., including some marine life news in the Virginia offshore wind farm and a Vineyard wind lawsuit and what the implications therein might be. Before we get going, be sure to subscribe to UPTIME Tech News. It's our weekly newsletter. You'll find that in the description links below, as well as Rosemary's YouTube channel. She continues to put out great content, has great guests, so be sure to subscribe there as well. So let's get kicked off today with this blade breakage. Rosemary, you're our resident blade expert. So this was a GE, I think from their Cypress line, a 5.3 megawatt. Is that right?
Yeah, that's what I've seen. And so that's the two-piece blade, where the tip comes separate from the root and it's assembled on site. So that's the exciting thing about that turbine. But when you look at the photos, I think that it broke quite close to the root. In the split blade design, it's only like the outer. I can't remember the exact dimensions, but I think it's like 12 meters, definitely less than 20 meters from the tip that is actually separated. And they do that because the loads at the blade root are just so large that, you really don't want to be putting a split in there and having a joint that has to carry that entire load. So yeah, I don't think it's anything to do with the split blade, the reason why it broke.
Alan, what's your take on this? This is out of the ordinary. Obviously got a bunch of press. Of course, every wind turbine blade breakage seems to get press, but why does this one seem noteworthy to you?
I think it's the second blade they've had break like this, and I haven't seen the review of the first blade breakage, but this one seems to be very similarly. At least that's the discussions online have been focused around, well, this is number two, not number one, and that kind of gets you into two areas really quickly. And Rosemary, correct me if I go off base here, but either they have some sort of design issue, which would be really hard to believe at this point, or they have a manufacturing issue, which definitely could be, a shipping issue where it's getting loaded unusually towards the hub, or they're having some weird lightning strike problem. All of those seem like possibilities right now. The shipping one, we've watched some shipping damage happen to blades.
Did this get hit by a train?
Yeah.
You see any train damage on this one?
Yeah, we've seen some really bad examples of blade damage. Well, shipping, there's a lot of shipping rash or damage that happens during shipping, but something that happens down towards the hub would be really unusual because Rosemary's right. The loads that area can carry are substantial. So you're talking about a massive structural failure here. And I can't imagine, and Rosemary, you would know for sure, but what happens after a blade has that sort of damage? What would GE typically do to go out and check out and inspect the blade? And what would be their sort of next sort of actions to look at it?
You mean it once the blade is folded in half, like in this situation?
Well, they would take it down, I assume, but someone's going to do a inspection of the blade to see what the root cause analysis, as part of root cause analysis, what was driving that failure, right? Isn't that the typical response?
Yeah. And so, I mean, the first thing to do is to really, as quickly as possible, try and figure out if it's a one-off or if it's a systematic thing. Because, you know, if you find out that all of your whole population of this type of blade is affected, then obviously there's a lot of wind farms around the world that would need to be paused while you figure out the solution. A lot of extremely unhappy customers.
Sure. So
they're going to want to figure out really, really quickly if they need to go down that path. And I mean, it's not a brand new blade, right? They have got some experience. So I think that it's not going to turn out to be some sort of really basic design problem. Yeah. I guess it's hard to say if we've had two blade failures. I actually haven't seen pictures of the first one that you're talking about, so I don't know how similar it looks. Two could definitely be a coincidence, even if they are in a similar place. But it definitely starts to make people want to, you know, dig in more carefully to see if this is a systematic problem. And yeah, it could have been any of the things you mentioned. And then I'll also add that it could be an impact damage, either, you know, while it was up tower, it could be hit by a drone or a particularly, damaging bird, or sometimes they get shot, or, you know, like it could be anything like that. Or something that happened in transport, like you said, not just, you know, like a damage from the loading on the ship, which would be a kind of design problem, but people drive into things with forklifts and, you know, like stuff happens and it doesn't always get caught. I mean, you do, when blades arrive on site, and then the customer is going to do an inspection while it's on the ground to make sure that they look okay. But it can be easy to miss something. You know, the blades are really, really big, really long. I think there's only a couple of turbines on this site, so they didn't have so many to look at, but often you've got hundreds. So,
there's two.
Yeah.
There's a community wind farm. Let's hope that they check them over properly, but there's any number of things that could be wrong. But I mean, if it goes on and we see more like this, then I'd probably be looking closely into what factory that these blades came from and whether they've got some mix up with work instructions. You know, it's easy to use an old work instruction and place a ply slightly wrong or something like that. That's a pretty common root cause analysis that I see when you see this kind of problem happening systematically. But at this point, I expect that they assume that it's a one-off or a two-off that happen to look similar. I think everyone's probably looking into it, but hoping really hard that it's not going to turn out to be a systematic error, because that's such a painful process.
Well, Rosemary, you raised a good question about the ply layup for each of these blades, and because you're making so many blades day after day after day, you kind of lose track, right? It'd be easy to miss a ply or to lay up a ply incorrectly. How do they prevent that in the factory? Are there ways to do that?
Yeah, they mostly they're using a lot of laser guidelines. So they'll have the blades are predominantly made by hand, but for the main structural plies, then they're going to have basically a robot that's holding a big roll of fabric of glass or carbon fiber fabric, and that will, help to get it in the right place. And then there's also going to be laser guidelines that are telling you they'll put a line down where the ply is supposed to start and stop. So, I mean, they really go to great lengths to make sure it happens exactly the same way every time. And they do achieve it with, I mean, I don't know another product that's so handmade that has such consistent quality. I think that it's really impressive what they're able to do. Where you see problems, it's because like maybe a process changed. If they had a slight design change where they moved something, and so but maybe a crew was using a paper instruction or something and didn't change over, and so they've got the new materials but using the old process. That's usually where you see problems, or maybe a repair, a problem with repairs, because all blades have defects when they're made and they have to be repaired in the factory. Sometimes they might use an old repair method, and it'll be something like that.
Well, Rosemary, you're going to be excited about this. Moving on, we might not need to bother with any of these blade inspections because vertical axis wind turbines are coming back. Did you hear the news? So if not, let me tell you.
Please.
The Department of Energy, their arm, the Advanced what do we got here? ARPA-E, which is the Advanced Research Projects Agency Energy. They have funded the University of Texas at Dallas to, essentially build this higher risk, higher payoff floating offshore wind project. So they're doing this. It's going to be a vertical axis floating turbine, and we're maybe going to see it in 2022. So obviously, like you've said, the commercial viability is tough, which is why the Department of Energy is having to fund this, because private investors, don't really want to put their money where it's so unproven and difficult. But having read this this article, what do you think about the idea of this finally coming to life, like a pretty large scale offshore vertical axis turbine?
Yeah, I mean, it's interesting. And last time I checked, vertical axis wind turbines also have blades. So I don't know if we're going to get away from blade problems.
Technicalities, whatever. All right. Well, it looks like an onion instead of, like
an egg beater.
A sunflower. Yeah.
And I mean, last time, this isn't the first time that vertical axis wind turbines have been really tried properly. Definitely, especially in the US in the 90s, especially, the government was funding a lot of research. People tried very hard, and there's actually a really great report from I don't know how you say, is it Sandia or Sandia? The US research, Sandia, the research lab, have a really great report that says everything that they learned from all of the attempts that they made with vertical axis wind turbines. So anybody who wants to try to commercialize this should take a look at that, because you can learn from their mistakes and from their challenges. And one of their biggest challenges was actually blade loading, because on a horizontal axis wind turbine, the blades are kind of, they're doing something quite similar to an aeroplane wing. It's always flying at the correct angle into the wind all the way along it, basically. And you try and keep that as steady as possible. But on a vertical axis wind turbine, when they're going, away from the wind, then they're flying in one direction. And then when they're coming back towards the wind, it's almost like an aeroplane flying upside down. So, I mean, it's not almost like that. It's pretty much exactly like that.
Right.
So, I mean, an airplane can fly upside down. So it's not like it's physically impossible, but it's really different loading. And so one of the most common early failures was from the blades failing from these just constantly changing loads, and a lot of stall loads, which are really violent, turbulent, cause a lot of fatigue problems. So, that hasn't changed. The loading environment hasn't changed so much. They'll be doing things to try and prevent these sudden changes in loads. So you can do things by, actively controlling the angle of attack of the blades throughout the cycle of revolution, so that it's not going to suddenly go into stall, and to make it a bit more gentle. And then the other big development that's happened since the 90s is with materials. So composite materials are, so much more advanced, obviously, than the aluminium materials that they were using mostly back then, easier to design so that fatigue isn't a problem. And I think that the design that the specific design we're talking about here is that Darius design, where you can actually have basically the whole blade in tension, which is really, well suited to composite materials. So I think it's worth another go. All the problems that they had back in the day are solvable with good engineering. This DOE program is they're not the only people trying to push vertical axis wind turbines. There's actually a few companies, private companies. C12 is one that's doing vertical axis offshore. And then there's some larger onshore ones as well, Agile. So, I mean, I'm interested to see how it turns out. I always think it's weird when people want to commercialize a technology offshore first, because it's like what you see with wave energy, how much it struggled compared to wind energy. Horizontal axis wind turbines, they matured their design onshore, had, like thousands upon thousands of hours of operating experience onshore, worked through all their problems in a way where, an environment where it's cheap and easy to get up and fix something when it breaks. Wave energy, most of the companies that have failed, it's been because they can't afford to, iterate a lot of times because it's so expensive to get out and fix a device once it's in the ocean. So, I mean, even if I wanted to end up offshore with a vertical axis wind turbine, I really think it's much more likely that whoever succeeds in doing that is going to succeed onshore first and then take it offshore. But that's a lot of companies are choosing not to do that. So, obviously there's differing opinions out there.
Alan, have you seen the megawatt size, the output of this one from UT? I've scoured and I couldn't find what it was.
No, I've only seen sort of general descriptions of what they intend to do, and the cost savings, and this is where the total cost of installation comes in, is that they think they can save a bunch of money on the floating part, or mounting it to the ocean floor, just because of the way the weight is distributed and the way the loads are distributed. So they're looking to save not so much on the turbine itself, but just on the way to get it out into the Gulf of Mexico in this case, which is really interesting because it's not just the cost of the turbine, it's the cost of everything, right? You're going to pay for all this stuff, and cutting one of those major expenses down considerably, and probably in the floating piece they can. Maybe it makes sense to do vertical, but as Rosemary said, there's a long way to go here.
And also, I mean, the reason why they expect the floating structure to be easier is because the tower is shorter, the center of gravity is lower. And I mean, I've seen a lot of articles that say, oh, they don't need this tall tower. But I mean, horizontal axis turbines don't need a large tower either, but you put a big tower on so that you can get to the good winds. It's less of an effect offshore. So I guess vertical axis have less of a handicap offshore for that reason, but it's kind of, it's a double-edged sword. It's an advantage and a disadvantage that they have the shorter tower.
Yeah, and of course, this is still going to be really tall. It's going to be 700 feet tall was their floating concept. Well, that's the actual size of it when it actually gets offshore, we'll see, but still not small. But yeah, like you said, the center of gravity is very different. Well, we will, Rosemary, you've been betting with everyone recently. I mean, do you want to wager with someone about this? You want to throw another $100 at this?
I've got no one to bet with. I don't think Alan's going to take the other side of that bet, that he thinks that vertical axis is going anywhere. I won't rule it out, though. I think it's similar to like multi-rotors of any kind. And another little snippet that these articles about vertical axis tend to raise is that you can have them operate more efficiently if you put them in pairs. You can have them that they affect each other in a kind of a positive way. And there is some research that's early stage research that suggests that it's just two-dimensional CFD. So, it's a long way from being a verified effect. But you get the same effect with horizontal axis wind turbines, that when you put them in pairs, and as long as you can control that so that they all as a group turn to face the wind, because it's important, how they're located relative to each other and relative to the wind. As long as you can control that, then you can get some like boosting effect, and get some structures that are, nicer to make floatable. So I do think that we're probably going to not just see turbines, offshore turbines continue to get huger and huger in the exact same kind of concept as what we've got. And I wouldn't rule out I wouldn't rule out vertical axis from, being part of that. So there's nothing, it's not like a scam, it's not a perpetual motion scam or something. These things do work. It's real engineering, real aerodynamics, and real structural design considerations. So yeah, I think it's worth researching as well. But I wouldn't invest in a company that was commercializing an offshore vertical axis wind turbine, because I think the odds are low. But the odds of any individual technology making it are probably low. So yeah, good on them.
Okay, well, no wager this week, I suppose, but we'll see. We'll see. That's all right. Thank you for your apology. I appreciate it. Moving on, there's a new potential ocean battery. Really interesting concept. Alan, do you want to explain how this works? This is an interesting article, but it sounds like there's a bladder and there's turbines and there's concrete. What do you got?
Yeah, so the concept is on the ocean floor around where turbines are located, on those off-peak times you want to store energy, or if you have excess energy you want to store, you can store it in essentially by pumping water through a system. It's sort of like a hydro storage. So on the surface of the floor of the ocean, you got these inflatable bags. You have basically a pump tower that penetrates down into the ocean floor a good bit. It looks like 20 feet or 30 feet down. And then you also bury in the ocean floor these solid tanks. And so what you do is you fill those tanks that are under the seafloor with water. And then as you have excess energy, you pump that water into the bags that are sitting on the seafloor. And when you want to reclaim that energy, the weight of the water from the ocean pushing on those bags will force the water through electric generator, which will create electricity. So it's sort of a localized way of storing energy mechanically in a hydro sense, in like a hydro dam sense, rather than storing it in a physical battery. So the concept is interesting. The piece I really couldn't figure out was how are you going to bury tanks in the bottom of the ocean floor consistently? Because I'm not sure we have a lot of knowledge in places like in the United States what that seafloor even looks like, and are we going to be able to bury that technology into the floor? And also, the second piece of it is just how reliable is it? That's what everybody's going to be concerned about. If I do the system and I can do the engineering and I can bury these canisters underneath the seabed, how long will it last? Is it going to last as long as the turbines? Maybe longer, maybe shorter? Don't know. So, but one of my 2022 predictions was offshore energy storage, and this is one of those concepts. So I'm still sticking to that 2022 prediction, but I'm not sure this is the right means yet. But it tells you there's a lot of activity in energy storage offshore. And Rosemary, do you see how this could be one of those energy storage means?
Yeah, I mean, it looks interesting. I'm sure it could work. It's got that same drawback that I'm always harping on about, that, like it's a new complicated thing that's underwater in the ocean, offshore a long way. So it's just going to be expensive to commercialize. If I had to put energy storage, I think it's a good idea to put associate energy storage with, with all kinds of variable renewables as the cost of that storage is, coming down. I'm 100% sure that if I was looking at this project and just looking at the outcome, I would put a bank of lithium ion batteries onshore, right. Just, near the offtake. I'm sure that would be cheaper, but that's not the way that you develop new, better solutions for the future. So I think we're in that time with, energy storage where all of the crazy ideas are being tried. And, I think this one, it's like a lot like a combination of a bunch of different existing things, like pumped hydro, compressed air. There's a buoyancy storage I've seen as well, raised as a possibility for offshore wind, where you've got like a big, beach ball and you pull it down, and then, let it release its energy when you let it raise. It's kind of similar to all those. I guess it's just a matter of waiting to see how things settle in a year or two, because I don't think we can just use lithium ion batteries for everything over the whole next decade. There's, it's going to be too much. So I think it is worth pursuing ideas like this.
Well, it won a Best of Innovation award at the CES 2022, which just happened like a week ago. But like you said, I mean, innovation is one thing, commercialization is another. As I look at it, I wonder, A, does this look like a whoopee cushion? Could they color it pink just because? That would be fun. But B, how big, what kind of material would this bladder be made out of? Could it really take a million cycles being really hot, or just being really cold down there and still be flexible? How often could it inflate and deflate without starting to crack? Rubber cracks over time, right?
Yeah. But it's very similar to...
It just seems like there could be a lot of issues. I don't know.
It's very similar to what Glenn Ryan was talking about with Bombora, which was a wave system, which had basically a bladder. As the tides came in and out, it pushed down on the bladder, and it would move water through a pump sort of thing, or air through a pump, and create electricity. So it's very similar to what has already been done and is going on in a similar place. So the technology isn't that far off, I don't think. We should ask Glenn for sure. He would know, but it would be really interesting to get his 2 cents on this design.
I was just thinking the same thing, that those design teams should talk, because I don't think the Bombora is also still at a demonstration kind of stage. So further ahead than what seems like it's just an idea at this point. So I'm sure
startup,
they could learn, but I think, we've got we've got a way to go before we find out all the problems with the design and how easy they are to solve.
So moving on, let's talk about microplastics. Obviously, one of the things that we don't talk about that much is how much of our car tires are in the air and then thus in our lungs. All these little bits of particulate from any sort of like plastic or rubber, that's actively in use in the environment seems to eventually erode off, ends up in either the waterways or the air. And this is also happening with wind turbine blades. So we know that with leading edge erosion, the edges are getting worn off, and that has to go somewhere, right? So when it's getting hit by ice or rain and it flecks off, even just the sand in the air, those little chips of the composite, the paint, the plastic, whatever, are off in the air. So, Alan, this article from Shetland News, which is overseas in the UK, I guess there's a dispute about how much microplastic is actually being shed off these blades, and that conflicting numbers from research and then from manufacturers they seem to be way off.
Yeah, they do. It really depends on who the manufacturer of the blade is and the technology in which they apply to the blade. Some blades seem to be a lot more erosion tolerant than other blades, and therefore the amount of mass that falls off of them is going to change dramatically. The numbers that got tossed around were about 50 grams per blade per year, which is about a tenth of a pound per blade per year. So each wind turbine roughly is going to drop about a third of a pound of debris into the water. That seems ballpark right to me. It could be say it's just a pound, but okay, fine. What is the consequence of that? And one of the, I think, points of confusion here is they were talking. The discussion was about BPA, bisphenol A, which is a component used in epoxy systems, and there's a health risk for humans that it can cause. There's a concern about birth defects. That's the big concern. So a lot of the debris that's actually coming off wind turbines is not epoxy. It's not bisphenol A loaded stuff. It's typically paint that's coming off, which is not epoxy. And so the toxicity goes way down, I think. Plus, I think there's just a question of, it's like one drop in the ocean. How much can that really affect anything? And that's realistically, that's probably what the answer is like, I'm dropping a third of a pound of stuff into this vast ocean. Does it even register anywhere? Probably not. No. But it is a concern. And as we start into some more of these ecologically sensitive areas with wind, do we have to think about some of the other consequences? If you drop hydraulic fluid in the ocean, which these turbines will at some point, oil, there's a variety of chemicals and pieces that make up a wind turbine. It wouldn't be surprising if some of them hit the water. And does it really matter? And is there limits on it? Are we watching it? Are we trying to minimize it? I think the answer to that is all yes. We're trying to minimize all of it. But is it going to stop a project? My feeling is no, because the environmental impact is going to, at least conceptually, it's going to be very, very small. And Rosemary, do you see that through the same lens as what I'm looking through from an engineering standpoint?
Yeah, I think the article that I read, there was a huge disagreement about the amount of plastics that were going to go in the ocean. So the figure that you mentioned was the one that came from somebody associated with the engineering of the wind turbines, and then the environmental group that's opposing the project guessed, I think, 65 kilos or, right, many kilos per year from each blade. And I think in the ruling, they just, it was ruled that was ridiculous, which, I mean, it obviously is ridiculous, because if you lost that much material off your blade, then your blade would be non-functional. So the manufacturer, the customer, everyone has every incentive to make sure that there isn't that much material loss. It's just, yeah, it's not possible. And in fact, even, the different materials, yes, some paint would be expected to be lost, but if you're losing epoxy, then you're also losing some of your blade structure. So again, that can only progress a very limited amount before there is much bigger problems for the owner of the wind turbine than, some amount of BPA in the ocean. So I think that there is already the right incentive for the operator and the manufacturer to ensure that this problem isn't any bigger than what they say it is. So, I think that I don't think it's such a big deal. I think, it's just like any other issue. You got to minimize the environmental impact, but anywhere that humans are, there's an impact on the environment. And, this number of grams per wind turbine per year is going to be small compared to, anybody that is, traveling through the area on boats constantly or,
right.
Doing stuff on the shore or, rubbish flowing into the ocean through rivers. I think all of those are bad impacts that need to be minimized and kind of taken as a whole.
Yeah, the discrepancy is, like you said, it's huge, and it wasn't just disputed by the manufacturer, but also by data from a university and from Norway. So, and like you said, if they're shedding 62 kilograms per year per turbine, that's 600. That's 1,200 kilos over the course of the lifetime of it. Like, that makes no sense. Like you said, it would just be a little eroded mass. Yeah. Yeah. So anyway, interesting story. Yeah. The microplastic stuff. It could be with all these things. How much atmospheric rubber from tires of cars is in the air? It's a lot. And obviously we didn't know certain things back in the day, like CFCs. We punched a huge hole in the ozone layer. Oh,
in
whoops,
our
guys.
ozone layer.
Sorry about that.
It's us in Australia that's suffering for that. It's me getting sunburnt.
Yeah, sorry, Rosemary. But so this could be one of those things. Obviously, it's not good for humans, but like you said, it's probably a pretty small contributor, which is, again, one of those. What's killing the world the most, Rosemary? The suburbs. People in the suburbs. I'm wagging my finger at all of you. If you all just moved to the city and you didn't drive your cars around, we wouldn't have any of these problems. There, I said it first. You heard it here first, folks. Cities are saving the world. But anyway, we'll keep an eye out on more microplastic stuff in the future. Let's shift to recycling. We talked about some of these things in the past. There's a new company in Warsaw giving some new life to wind turbine blades. Obviously, this is not going to solve the gigantic quantity of blades that will be coming offline. But I guess every little bit gets reused, whether it's to be made into a cool park bench or seating or something else. It's pretty interesting. Alan, do you think more firms are going to start popping up to just sort of take this stuff? Or does this stuff seem... It just doesn't seem to me like, even though some of these are really beautiful, it doesn't seem like they're going to be in mass quantity. Like, could you see a couple of turbine things in every public park? I think you could, but it doesn't seem like... They seem pretty one-off, right?
Yeah, but there's many firms that are... businesses that are doing this. I think I recently saw one, I think it was in Ireland or in the UK, that was doing exactly the same thing. They were reclaiming sections of wind turbine blades to make them into structures. The one I remember was like a podium or a lectern. Oh, that's an interesting idea because it's already sort of pretty close to that shape. And so they just adapted it over. So we are reclaiming some wind turbine blades for architectural purposes and even structural purposes, which is like a pedestrian crossing bridge and things that structure will totally handle. It's just one of many ways we're going to learn to recycle, reuse wind turbine blades. And as more opportunity arises, as there's more businesses trying different things, we're going to find that niche, whether it be just recycling in terms of make it into cement or make it into park benches. I think there's a place for them rather than burying them in the ground.
Well, are they big enough? Rosemary, you're a big outdoorsy person. Could we make like a whole campsite of structures? Could you have like 30 little, 2-bedroom things made at a campsite where you can just repurpose them that way?
Of course you could. And in Denmark, their campsites, I guess because it rains so much, but the camp areas there are usually like some sort of wooden structure with, like one open side and then the rest of it's like a kind of like a box that you kind of slot into. You bring your sleeping bag and you don't really need a tent. So that could easily be made out of pieces of wind turbines. But I think that, Like, I don't want every single piece of outdoor furniture, every single bike shelter, every single bridge to just look like a wind turbine.
It's all wind turbines.
Blade.
Yeah.
That's not what I hope for the future, but I don't think it's going to be like that. I do think we'll see a lot more of this reuse because it's such a valuable material. You know, like it is a high performance material. It's reached the end of its lifetime for a wind turbine blade application, which is so demanding. But you know, that's basically the most demanding thing you could do with a material. You can make nearly anything out of it, and afterwards, and the structural properties will be just fine. But I think it's going to rely on, there needs to be like another evolution, as much as the designs in that article, like they're actually mostly pretty nice to look at. So, I thought they were good, but I think it's going to be more a matter of working with like modern design and architectural techniques. There's a lot of things they can do now to, like if you look, for example, at how they're using natural materials more in design, using, you know, like curved pieces of wood and stuff. And there's a lot of good computer software now where you can scan the exact shape of something and then, you know, put that into a computer model. So you might be slicing up into smaller pieces. So you've got some curves, but it's not, you know, when you arrange them to form a framework or something, it doesn't just scream wind turbine blade at you. And, I can imagine, you know, in a few years, we'll get to the point where we see things reused in a way that it's just a nice material. So I think we're getting closer.
Well, something that could be like, for example, like hardwood flooring. You'd think there'd be some way to, you know, sand down one side of a blade, you know, put it through a router or something where it's flat, start cutting it up with a CNC machine into essentially composite flooring. I don't know if fiberglass is like the healthiest thing to have in your house. I have no idea. I mean, you guys would know more than I would, but things like that seem like they could have good uses where you can maybe put cheap but really durable flooring and like, I don't know, all sorts of different applications, right? Maybe not in like high-end homes, but maybe in like lower-end homes or, I don't know, common areas or something, or baseboards, for example, or, you know, molding for your house. So maybe it'll get there. We'll see. Well, speaking of which, getting these blades off the turbines themselves is an interesting challenge. And there's an interesting story from North Dakota where they're talking about dismantling a wind farm. And I guess one of Alan, is this the way they're proposing to do it? Is this the final way they are going to do it, which is they're going to take a crane, mount it on a truck to remove the blades, and then at each tower they're going to put a cable up top. They're going to remove some of the gussets at the bottom, right, and then they're just going to have a bulldozer sort of back up,
pull it over from
a long way away, I'm sure, and just pull it over like a tree. Is that is that the final way they're going to do this?
Yes, which is very odd because I haven't seen that technique used before. What I've seen, if you check YouTube, is sort of a explosive demolition, controlled explosives, where they're cutting the base of the turbine and slicing it, and then the whole turbine comes over, blades, nacelle, everything rolls over. There's pictures of that happening in New Mexico and West Texas, what I remember from the recent YouTube videos. So I thought North Dakota would be doing the same thing, but they are very concerned about reclaiming the land in which the wind turbine falls onto, and in relation to crops and falling onto roads, things of that sort. So they really want to control where the demolition takes place at. But I would assume it's going to cost you a pretty good penny to take the blades off, set them down because of the crane expense, and then to pull the top over would be expensive. But so it's unique. I was not expecting North Dakota to have those kind of constraints. It's different.
Well, and this seems like if you gave 3 high school boys with a pickup truck and you said, hey, go take that wind farm down, this is exactly how they would do it.
Yeah, they would, yeah.
But it seems they said they're going this route because it's going to save them, what is it, $6 million?
Yeah, it's a lot of money.
So I don't know. Rosemary, what do you know about dismantling wind farms?
I don't know a lot, and I haven't even taken the time to look it up on YouTube, but now I feel like I have to afterwards to see what they're doing. But I think that the whole point is if you can say you're going to decommission your wind farm in this cheaper way, then you need to set aside less money to do that. And so it's, you know, a financial incentive for the developer to find the cheapest way. And I guess that there's some contention about like you won't actually know how much it costs to decommission until you actually do. And when you're starting a wind farm, that's, like 20, 30 years in the future. So it is one of those perennial topics where people argue about whether enough money has been set aside for decommissioning. And it's a question I get asked about so much on my YouTube channel. And similar question for nuclear, especially that a lot of people think that the money set aside to decommission nuclear power plants that are about to retire is not nearly enough. Problems with coal power plants that are going bankrupt, and it depends on how the government has regulated that money has to be set aside, whether or not a bankrupt company still has the resources to decommission safely. So I think if you put in the scale of all the different ways that you can generate electricity, then wind probably has one of the smallest decommissioning problems or decommissioning kind of time bombs out of all of the options. But it's definitely a consideration, and it's something that people worry about. Like the community is worried about what's going to happen at the end of life.
Well, you'd think that North Dakota would take some state pride and maybe see if their football team could pull this down. Use make a little sled, and just have the players very far away the long chain. But then you'd imagine 20 linemen could probably pull that thing down. I think so.
Okay,
Alan.
so here's a bet for you that our rugby team will take it down better than any North American football team, because that is not a tough sport. I'm sorry, no, they've got helmets on, they've got shoulder pads. I mean, look at the difference between a rugby tackle and the difference in
the difference in size between an NFL linebacker and a rugby player is huge. Not to mention these linemen are 300 plus pounds. How many rugby players could tackle them?
But a rugby player can run. That's
many.
The difference.
He's better.
You've actually got to move.
Yeah, an NFL linebacker. An average NFL linebacker is significantly bigger than the average rugby player. Very
can
much
they move?
Bigger.
Can they run?
Oh, the linebackers, they can move so fast. They're one of the, they have the highest vertical jump of all Olympic athletes next to Olympic weightlifters.
So I'm taking that bet.
No, I don't believe it if they're so heavy.
That's true. Yeah. NFL line. This is strength to weight ratio.
Crazy strong. Yeah.
So we can if anyone's out there, if you want to coordinate the Aussies versus the I don't know Alan, who we got here, the New England Patriots.
The Patriots, yeah.
My money's on the Patriots. Yeah,
I'll take that bet.
Take less of them. Yeah. Okay. Well, this is good. We got a wager out of the way here. So anyway, pretty interesting. I want YouTube footage of this. If anyone's listening, please film this. Go out to North Dakota and film this for us. Rosemary, you should be on this team, by the way. This should be on your channel. So moving on, in Virginia, one of their offshore farms, not a floating one, they've done some drone footage of these sort of like lattice work structures that are, beneath these wind turbines. And they found like a really thriving ecosystem. Alan, does this surprise you that marine life, I mean, it seems like if you do anything, we know if you sink boats in the water, and a lot of times boats are decommissioned by being sunk, right? It forms sort of like a natural reef, and it seems like that's what's happening here off the coast of Virginia.
Yeah, I think that's to be expected. Anytime you drop any structural piece in the ocean, it seems to make it into a reef pretty quickly, where all the little fish come and all the plant life grabs hold of it and makes it into a vibrant community of some sort. And these wind turbines off the coast of Virginia haven't been there all that long. There's only 2 of them, so it's part of a demonstrator process for Dominion Energy is to go out there and put these turbines out, because they're going to be putting a lot more turbines out in the water in the next couple of years, and so they're trying to get some data on what happens. And I think from the engineering perspective, that makes a ton of sense to me. Let's see what's happening, and if we need to make adjustments to the turbines themselves. As Dan, you're right, because those bases that get driven into the seafloor, they're not closed cylinders. There's actually holes in them to let the tide come in and out, and the waves come in and out. So the fish actually crawl up inside the turbine towers, which is really interesting, because I didn't realize that was the thing. But it creates more sea life, essentially. And the question in my mind is it beneficial to the wind turbine, or is it going to be a problem later on because all that sea life is around? And that's what I don't think we know a lot about yet. And I think the other piece is what happens on the environmental side. because there's a lot of concern about habitats for native species in these areas, in these offshore areas that we don't know a lot about. And if we start driving big pilings into the ground, do we upset that ecostructure, or is it temporary? If it is upset, is it temporary? Is it long term? Or do we just have this basically another place for fish to grow? Don't know. But at least we're doing it in the right manner, in my opinion. We're doing it slow. We're actually having scientists go out and take a look. And a lot of these offshore wind sites and developers actually have a person on their staff who's just looking at the fisheries, which I wouldn't have expected. But it makes a total sense once you hear it. Like the local fisheries are concerned about it. So why not have an expert document what's happening? And Rosemary, I'm surprised I haven't seen a lot of activity like this over on the European side, but it's a big issue here in the United States. Is it a bigger issue than Europe? We just haven't seen it?
I haven't heard about it, so potentially not. But I mean, to me, it's very obvious that you put a structure in the ocean and it's good for fish, good for coral reefs or whatever, because like you said, they purposely sink boats to create environments like that. So we already knew what happens, around oil rigs or whatever once they're decommissioned. So, I mean, why would it be any different because it's there for a wind turbine instead of for, some other purpose? So maybe that's the reason why we haven't seen a lot about it. I mean, I'd be highly surprised if no one has taken a look at what's going on around a offshore wind foundation in Europe somewhere, because they've had them since, the first ones were in the 90s. So, they've had plenty of times for things to grow on there. Obviously there's people who like to dive and snorkel in those countries. I'm sure it's well known, but maybe it's precisely because it's brand new now in North America that people are, taking a look at it with fresh eyes and want to know about, every possible consequence, whereas it's maybe more normal in Europe by now.
All right, moving on, but staying with offshore. So our last topic for today is the Vineyard wind farm, which has been embattled recently, and of course, more so now. There's a new lawsuit filed in conjunction with a Texas group that is pretty hostile towards wind energy. And they're basically claiming that a lot of the diligence around and the environmental studies and the right whale specifically just wasn't done thoroughly enough. So new lawsuit filed claims that they did not provide BOEM with alternative lease sites in connection with endangered species, specifically the right whales. They also assert that they did not properly establish an environmental baseline, which has another number of downstream effects. They said that there's been inadequate incidental take statements that failed to account for all effects to endangered species, including the right whales, and that they failed to reinitiate consultation after getting new data when they altered their project to include Haliade-X, which were significantly larger turbines than originally proposed. So, Alan, obviously, we've recently learned from one of our upcoming guests that when these lawsuits reach the court, the judge is more or less sifting through to figure out, was diligence done properly? Like, the court is not the expert on this. The experts are the expert, but the judge is going to intervene and say, yes, were all these channels properly attended to? Was everything done by the book? Was everything done properly? Were all things considered in the way that are reasonable? I don't know the exact language here. Was this all done well? And so the question is, you seem like there's so many smart attorneys on this. You wonder that this many claims would have really fallen short, or is this just another piece of litigation that maybe is aimed just to sort of slow this down?
Well, that's a good question. And as this next podcast is going to come out, we're going to talk a lot more about leases and auctions. There's a lot of review that happens before the sale or lease of the plot of ocean takes place. A lot of environmental review, a lot of discussion within the community, nationally, locally. So by the time they get, like Vineyard Wind gets to this point, it'd be hard pressed to think that they skipped over something as obvious as whales, which is a huge industry along the coastline there, tourist industry along the coastline. And so that one doesn't feel right to me in terms of everybody just looked the other way. doubt that is the case here, right? But in the way that American society is structured, you have a right to bring a lawsuit and to make your claims in a hearing and let your voice be heard. Okay. So I'd rather have that and get it out in the open and everybody figure out what happened and get to a conclusion than the constant squabbling that appears to go on, and there's never ever a resolution here. The resolution is the important part, because either Vineyard Wind's going to put turbines in or they're not. What is damaging to Vineyard Wind is a 5-year lawsuit, and they're continuing to pay money out for the lease and the rent and everything else, and you get no production of electricity. That's just going to set back offshore wind a long time in the States. And Rosemary, I don't think the Australian system is set up like the United States, where it seems like if anybody has an issue, they run right to court and try to create injunctions to stop things. But it seems like there's just, in the different parts of Europe, there's a little more environmental oversight way up front. So these type of issues don't come to this sort of clash in the courtroom. Am I right about that?
Yeah, I'm not sure. I mean, I don't think it's so different in Australia. And usually when I'm paying attention to these kinds of environmental lawsuits, it's because, they want to do a gigantic new coal mine, or they want to dredge the Great Barrier Reef so that they can export that coal. And, and so we have lots of environmental assessments and approval processes that need to happen in Australia. And I'm often not feeling like they've really done a very good job, that it's more about whether the politician just likes the idea of the project, has an ideological, commitment to that type of energy, or got a donation from one of the developers. That's how it feels to me as a concerned citizen in those cases. So yeah, I don't see that it's so different. Of course, America's always more litigious than basically everywhere else. So there's that. But it seems to me like part of the problem is just that you're still very early in your journey towards offshore wind in the US, and I mean further ahead than Australia is currently. But I don't think that you could have this same lawsuit for every offshore wind farm where there were whales in the area. I feel like for once and for all, they're going to say, okay, yes, we know there's whales in the area and we've ruled that they're not going to be affected by this. It'll be very hard, once there's been that ruling, for the same kind of lawsuit to, make any progress on another wind farm where there's whales in the area. I mean, surely. And I would hope that this could be settled by taking a look at some European offshore wind farms where there were whales in the area and having a look to see if they were really that bothered by it. Because my instinct would be that, whales have coped with a lot of human impacts in the ocean over the years, ships and any kind of offshore oil and gas infrastructure. You don't want to be putting a lot of obstacles in their way, but then again, I feel like a whale can swim around a turbine. I feel like that's not such a big deal. It also seems like there's a little bit of conflicting stuff in here. It's like, on the one hand, this is bad because it's going to be bad for fisheries, and on the other hand, it's going to be bad for fish. And I feel like you can't be both bad for fisheries and for fish. Like if you stop people fishing, then isn't that good for fish? That's what I would expect. Not that I don't think whales are fish. I just want to add that. I know whales aren't fish, but yeah.
Yeah. If anything, protecting some of the water from heavy commercial fishing is got to be obviously good for fish, right? Because we're decimating the population of anything that we can eat here in the U.S. So yeah, it can't be bad long term, but
yeah, and bigger animals eat the fish, and so you would think that it could just as easily, or probably more likely, have a beneficial impact on keeping everything a bit more natural.
Yeah, well, I just feel like in Australia, you guys just know, with that huge hole in the ozone layer, you don't have as much time to waste in court. You got to get out there and live your life before the complete lack of protection from the sun does you all in. So maybe that's where our systems of our legal systems differ. But yeah, so we'll see. I mean, Alan, do you think this is going to get wrapped up soon, or do you think Vineyard Wind is going to continue to be bombarded with more lawsuits?
It seems like this lawsuit's not going to go very far, because as long as BOEM and all the environmental impacts were done ahead of time, this should be,
if they did their job, yeah.
It should go through the legal system and get reviewed and say, no, everybody's done their job and it's okay. We're not to say we're not going to monitor it. And there's a lot more, because remember that it's not just the lease that happens. Before anything can get installed, there's another environmental review, which is what's happening now and why this issue is coming up. Is there's another stoppage point where everybody needs to collect their thoughts, make sure the next stage is going to be okay. So there are built-in pauses into the system. This is one of them, but I think the previous 5-10 years worth of work, and Rosemary's right. If they have data from Europe also, that's going to bolster their case to say, I think it's going to be okay and we're going to move on. So good. It needs that level of review. It definitely needs review.
All right, well, that's going to do it for this week's episode of the Uptime Wind Energy Podcast. Thanks so much for listening. Be sure to subscribe wherever you listen on iTunes, Spotify, Stitcher, or if you watch us here on YouTube. Be sure to share the show with a friend. Leave us a review. We'd really appreciate it. And we will see you here next week on Uptime. Operating a profitable wind farm is all about mitigating costs, minimizing risks, and being efficient with maintenance, repairs, and upgrades. It's incredibly expensive to send a team of rope access technicians up tower to make even simple repairs. We also know how costly lightning damage can be, requiring inspection, repairs, and downtime for even minor lightning strikes. Maximize the time efficiency of your techs and prevent future lightning damage by installing our Strike Tape LPS upgrade the next time your crews are going up on ropes. Learn more in today's show notes or visit us on the web at weatherguardwind.com.